Hi, this is Greg Monty. I'm the director of the Center for Energy Research and Technology at North Carolina A&T State University, and this is the CERT educational series, and the specific topic for this learning module is third grade heat transfer. So let's get started. We're going to do an experiment today in class, and to do this experiment you're going to need to know what conductors and insulators are, how to read a thermometer, how to record data, the numbers from the thermometer, and how to look at information from the experiment to understand what happened. First, let's talk about a conductor. What is a conductor? It's a material that heat moves through easily. Can you think of some conductors? Cooking pots, like the one on the left, is a good conductor of heat. Window glass conducts heat. And metal forks and spoons. All good examples, and you probably came up with some yourselves. So what's an insulator? An insulator is a material that heat does not move through easily. Are you wearing an insulator today? Your clothes insulate you from the heat or cold. Shoes do the same, and a hat, which you're probably not wearing in the classroom. Information you'll be collecting today. Temperatures or numbers from thermometers will be written in a table on your lab sheet. Your sense of touch will be used to feel the metal bar in the experiment. What is a thermometer? A thermometer measures temperature. What is temperature? The answer is temperature is a measure of how warm or cold something is. The unit of temperature is degrees. The symbol for degree is a raised small circle, a tiny raised circle, and in our case we're going to be using degrees Fahrenheit in this lesson. How do we read a thermometer? Let's look at the picture on the left and read the number. What number do you see? The answer is 160.0 degrees Fahrenheit. Notice the dot between the two zeros. The dot is the decimal in this case. How to record data for this experiment. You're going to have a chart like the one on the left. It's in your lab sheet. And when we begin, one student will read the number from the thermometer in cup A, the hot cup, and everyone in the group writes the number in the chart on the lab sheet. Then the same student will read the number from the cold B cup, and everyone will write that number in the chart on the lab sheet. So let's do an example. This isn't the actual experiment, but we're going to show you what you're going to be doing, recording your data. We start with a chart. For example, a student's going to read a thermometer in cup A and tells the group that it's 140 degrees Fahrenheit. Then the same student reads cup B and tells the group that it's 73.4 degrees Fahrenheit. Everyone in the group would write these two numbers across from reading one when we do the actual experiment. This would continue, and when instructed, another student in the group would read the thermometers and share the numbers with everybody. And then the student would read both the numbers on the thermometers in both cups. And everyone in the group would again write these two numbers across from reading 2 when we do the actual experiment. When you are instructed, another student will read the number on the thermometers and tell the other students the numbers, and the experiment will continue until the table is filled out. And there will be a delay between readings of about 1 minute, and a bell will ring to help guide you through the experiment. So let's talk about the experimental setup so you understand what we're going to be doing. The teacher, possibly with a couple of students, will set up and deliver one experimental setup to each of your tables or stations while you watch this short video. And I'm going to give you a quick demonstration of the equipment you're going to use in your experiment today. I'm going to tilt this down so you can see everything. First of all, you're going to have a A cup and a B cup. The B cup is going to be filled with some cold water, a little bit at the bottom of the cup. And then the A cup is going to contain hot water for this experiment. So I'm going to pour some hot water into the A cup. And then the experiment that you're going to do is going to involve an aluminum bar, which is placed through a couple of foam lids. It's going to connect the two cups together. One foam lid will go into the A cup or the hot water, one will go into the B cup or the cold water. And also a thermometer will be pushed through a small slot on these two foam lids. And the thermometer's on-off button is on top, and your teacher or students up front will help to get this ready and turn on the thermometer, and they should be set to Fahrenheit for the experiment today. So this is what the setup's going to look like for you. You're going to be reading the thermometers, and they're going to be set up on the Fahrenheit measurement, hot water in A and cold water in B. And that's your complete setup. Have a great experiment. So let's first take a look at what the metal bar feels like before the experiment begins. A few students in the class will touch a metal bar on both ends that's being displayed by your teacher. How does the metal bar feel before the experiment? The answer is that the metal bar feels the same on both ends of the bar. So let's begin the experiment. You have a setup at your station, and we're going to first feel the metal bar at the beginning of this experiment. Everyone should touch the metal bar near cup A and cup B. Do you feel a difference in temperature on the bar? Now touch the outside of the cups. Do you feel a difference in temperature outside the cups? Now we're going to take reading 1. The bell just rang, so I'd like one person in your group to read the temperature in degrees Fahrenheit in the hot cup and in the cold cup. And write that in your lab sheets, all of you. The next thing that's going to happen is going to be taking reading 2, but we're not going to do that until the bell rings. There's going to be a delay so that the temperatures can change in the cups of this experiment. And it's approximately 1 minute between recording and taking data. So let's just wait, and when the bell rings, we'll take reading 2. All right, so everybody should have someone at the table, someone different, to read reading 2 from both of the thermometers and record them in your data sheets. We're going to continue. We've now filled in reading 1 and reading 2, and we're going to take reading 3 when the next bell rings. Okay, so one other person is going to read the 2 thermometers and record the degrees Fahrenheit for reading 3. Now as we continue, I want you to again touch the bar near cup A and cup B. And do you feel any change between the beginning of the experiment and now? And also touch the outside of the cups. Do you feel a difference in temperature outside the cups from the beginning of the experiment? You might make a note of this in your data sheets. The next thing we're going to do is take reading 4, and we're going to do that again when the next bell rings. You could start to look at the data in your data sheet and see if you see any trends or changes taking place in the temperatures for either the hot cup or the cold cup. Okay, another person should read the 2 thermometers and record that data under reading 4. We'll wait another 45 seconds or so for the next bell, and we'll take reading 5. Okay, take reading 5. And we'll have one final reading to complete our charts in our data sheets, and that will be taken when the final bell rings. Alright, so now the last reading is taken by reading the thermometers in cup A and in cup B and recording the degrees Fahrenheit. You should have a completed chart now in your data sheets. And now we're going to think about what took place during this experiment. We're now at the end of the experiment, and everyone should touch the metal bar again near cup A and cup B. And do you feel a change between the beginning of the experiment and now? Do you remember what it felt like? And touch the outsides of the cups. Do you feel a difference in temperature outside the cups, especially as compared to the beginning of the experiment? Let's look at the data and information in your data sheets. How did the metal bar feel at the end of the experiment? Was it different than at the beginning? The answer is that the metal bar became warmer near the cold water cup. Let's also look at the temperatures in the data table. What happened to the temperatures of the water? After looking at your data sheets, I think you probably noticed that the hot cup temperature went down and the cold cup temperature went up. What happened in the experiment? Why did the metal bar become warmer near the cold water? It's because heat from the hot water traveled through the metal bar by conduction and into the cold water. Heat moves from hot to cold. This is a very important concept. Heat always moves from the hot body or hot material to the cold body or cold material. Let's label our picture. We want to use our vocabulary words. Thermometer, conductor, or the metal bar. An insulator, both the cups and the lids are good insulators in this experiment. And heat flow, the direction of heat flow. Which direction did the heat flow between cups A and B? What we want you to do is draw these words onto the picture that you have in your data sheets. Also, make sure that you put the direction of the heat flow. Draw an arrow to show the direction for heat. So here's the picture that you should have. You have the hot cup on the left and the cold B cup on the right. The thermometers are the yellow looking thermometers, just like in your experiment. The conductor is the gray aluminum bar that reaches into the water on both cups. You have insulators, both the foam lid and the foam cup itself are good insulators. And note, as we said, heat flows from hot to cold, so the direction of heat flow is from left to right in this picture. So let's talk about some everyday examples. Have you ever made a glass of iced tea? I think probably you have. We have a picture on the right showing some tea with some ice cubes in it. And we know that the beginning temperature of that tea is about 70 degrees Fahrenheit, or room temperature approximately. And the temperature of the ice is about 32 degrees Fahrenheit. So what happens to the temperature of the tea as the ice melts? So I think you all knew this because you've all drank cold water or iced tea before. It gets colder. The temperature of the tea gets colder. But why? Why does it get colder? The answer is that when heat leaves the tea to melt the ice, the temperature of the tea goes down. This is just like in the experiment. We had a hot cup of water and a cold cup of water, and the heat was leaving the hot water through the aluminum bar and getting into the cold water. So heat was being transferred from hot to cold. The same thing happens here. The 70-degree tea releases its heat, melts the ice, and the temperature of that 70-degree tea goes down, in this case, to 50 degrees Fahrenheit. Let's ask another question. How will you feel if you stay in a pool for a long time? Normally you're going to feel colder, unless you're just jumping around a lot. But why do we feel colder when we sit in a pool for a while? It's because heat flows from your warmer body into the lower temperature pool water. Your body temperature is around 98, and the pool water is typically in the 70s or 80s. So it's definitely cooler, and if you stay in the water for a long time, the heat from your body gets transferred to the pool, and you begin to feel cold. Remember, it's hot to cold. You release body from your heat into the water. Remember this hot to cold. Heat always transfers in that direction. I want to thank you for participating in the CERT Educational Series. This is the end of the experiment, and we hope to see you soon in another educational module of ours. Thank you. Bye.